Thanks, John. So this is from my second paper of my PhD thesis. It's called Survey Mode Change by Necessity, Evaluating Survey Representativeness During a Global Pandemic. And this paper is being supervised by Jamie Moore, who spoke in the previous presentation. So I'm going to start and talk a bit about representativeness, and then I'm going to talk about the data that I'm using and then the initial findings. So general population panel surveys aim to collect data from a sample that describes a target population, typically a country over time. So representativeness is when the survey population is sampled such that the survey estimates reflect those observed in the population. And therefore, measuring representativeness can be used as an indicator for survey quality. And I'm now going to talk about some of the issues that are related to representativeness. So non-response and attrition, they're inevitable parts of the survey process and can affect representativeness, especially when it's non-random, as participation of specific groups of respondents lead to biased survey estimates and increased variances, and that leads to an unrepresentative sample. Representativeness is also inherently related to estimated parameters, and therefore what might be representative for one set of variables may be misrepresentative for another set of variables. So for multi-purpose surveys like Understanding Society, there's a compromise to ensure that the sample is representative as it can be given the various analytical purposes. And again, for longitudinal surveys like Understanding Society, the concept of representativeness is more complex because of its dynamic nature. The population is ever changing and experiences changes such as birth, death, and migration, which can affect representativeness over time. So response rates are commonly used as an indicator of survey quality as they're easy to calculate and interpret. However, surveys with high response rates can still suffer from non-response bias. So relying on response rates alone can be problematic. And surveys with high response rates can also have low representativeness. So two indicators that can be used to measure representativeness are R indicators and coefficients of variation, also known as CVs. Both are calculated using auxiliary data, and auxiliary data is data that is available for both respondents and non-respondents. So that can be admin data, sampling frame data, and survey para data. Both are dependent on the availability and suitability of the auxiliary variables and should correlate with the probability of response and variables of interest. So the R indicator is the transform standard deviation of the response propensities, and it ranges from 0 to 1, where 0 indicates weak representativeness and 1 indicates strong representativeness. The CV is the bias-adjusted standard error of the response propensities divided by the average response propensities, and lower values indicate strong representativeness. So both versions have full and partial versions, and the full versions just show the magnitude of the bias, but cannot identify specific survey variables that contribute to that bias. So that's where the partial variants become important, because they're measured at the auxiliary variable level and can show which auxiliary variables contribute to that bias. And it also can show which categories within the auxiliary variable are overrepresented or underrepresented. And the partial variants are used in addition to the full versions and not independent of. The partial variants also have unconditional and conditional forms. So unconditional is where it measures how much a single variable contributes to the lack of representativeness. And the conditional does the same, but it takes into account the other auxiliary variables in the model. And it can be used to illustrate those groups that we want to target for, say, targeted intervention, such as incentives to encourage certain groups to participate. So for time constraints today, I'm just going to be focusing on the results from the unconditional CVs. So the CV is also preferred over the R indicator when comparing representativeness in cases where response rates vary, because it's standardized by the mean of response propensities. And then I use R syntax from the risk project, and that's how I calculate both of these indicators. And I've got some references there, and I'll show references at the end. So survey mode is an important issue for sample representativeness, as the survey mode can be related to the participant's decision to respond, and that can lead to those subgroup biases that I was talking about before. So for face-to-face, it's associated with higher response rates compared to other modes, but also has higher financial and time costs, whereas web can reach a wider range of individuals without the need for interviewers. But that's also associated with lower response rates compared to other modes. So it can be difficult for general population surveys to rely on web only, which is why face-to-face remains dominant and mixed mode approaches are preferred. But also with web mode, sampling and non-response biases related to access to internet plays a role. So those who there might be certain groups of people who are less likely to have access to the internet or less likely to be comfortable with using the internet. And also it's worth noting that changing mode in the middle of a survey can be harmful to response rates. And I'll go into this in the next slide. So the COVID-19 pandemic changed the way in which surveys are administered. Face-to-face interviewing had to be suspended to comply with lockdown and social distancing policies. And it also created the need for rapid COVID-19 related research, such as the Understanding Society COVID-19 survey. And little is known about creating a survey where the typical mode is not available, especially when it's outside of the survey organization's control. The setup time is significantly decreased and the frequency of the data collection has changed. And more specifically, little is known about how these changes impact data quality, such as representativeness. So my first research question is it possible to achieve a longitudinal representative online probability sample for a sample that had previously mostly been face-to-face during a global pandemic where this mode is not now available? And the second question is, how does the representativeness compare with the representativeness of the original mixed mode annual sample? And I used two samples for this research. One is the Understanding Society main survey, and one is the Understanding Society COVID-19 survey. So the Understanding Society main survey started in 2009 and is ongoing. It's an annual household panel survey, and it's mixed mode using face-to-face, web, and a small amount of telephone interviews. And I use wave 1 to wave 10, and that's about 48,000 individuals. And it's those who completed a full individual interview at wave 1 for 2020, and it's ongoing, and it's a monthly individual survey, or monthly until July, and then bi-monthly going forward. And then I only used the web sample, as the telephone was more supplementary and they didn't have telephone interviews at every single wave. So I use wave 1 to wave 8, and that's a sample of about 16,000 individuals who completed a full individual interview at wave 1. So again, it's worth noting that the COVID survey was sampled from active sample members from the Understanding Society main survey, and I'll address why this is important in the next slide. So I used 7 auxiliary variables. I've missed one off this table, but I use gender, ethnicity, employment status, marital status, highest qualification, household composition, and age. The auxiliary variables were taken from wave 1 for both surveys, so that we have information for respondents and non-respondents, because I'm using wave 1 respondents as my base. And then the auxiliary variables selected here were chosen because of known effects to response propensities in understanding society. And also to compare the surveys, the same auxiliary variables have to be used. So the COVID survey, as mentioned in the previous slide, was sampled from active main survey members. So we've got the same auxiliary variables being used here. And that is from wave. So for COVID wave 1, I'm using the main survey wave 9 as the base, because that's when they started around the same time. So this graph shows the COVID survey and like the overall indicators. So I've got the response rate in blue, the R indicator in red, and the CV in green. So you can see that the response rate for the COVID survey is pretty high. It remains high from wave 2 to wave 8 at 0.8. And then the R indicator, higher values indicate strong representativeness. So you can see that it shows strong representativeness in this survey, and that the CV lower values indicate stronger representativeness. So it's showing the same, the R indicator and the CV is showing that the COVID survey is representative. And then for the main survey, you can see that the response rate declines over time from about 0.7 to 0.4, but it's worth noting that this is a period of over 10 years, whereas the COVID sample is a period of about a year. So the R indicator still remains pretty high, showing that it's a strong representativeness over the 10 years. The CV increases over time, which shows that the representativeness decreases over time. And here we can see that the CV and the R indicator are different. And as I mentioned before, the CV is preferred when the response rates are different. So between the COVID survey and the main survey. So going forward, representativeness. So this shows the unconditional partial CV for the COVID survey. And you can see the 7 auxiliary variables here. I'm not sure if you can see what they are, but the ones at the top are age, household composition, and employment status. So the CV kind of gradually increases over time, but from wave 7 to wave 8, it decreases. So it shows that the representativeness decreases over time and then slightly picks up again at wave 8. And the bottom one is gender, and that remains pretty stable with high representativeness. So for the main survey, this is the unconditional partial CV. All of the auxiliary variables increase over time, which means the representativeness decreases over time. And 2 auxiliary variables that are worth noting are age, which is the one at the top, and highest qualification, which is the second one. And yeah, they just show that the representativeness decreases over time. So I'm now going to focus a bit on age, because that was a key variable from the last 2. So these are the categories within age. So we've got age 16 to 19, 20 to 34, 20 to 24, 25 to 34, 35 to 44, 45 to 54, 55 to 64, and 65 plus. So this shows the 2 lines at the top show that those are the groups that are overrepresented, and you can see like a 0 in the middle. Maybe you can't see it, but there's a 0 in the middle, and then you've got negative values towards the bottom. So positive values are overrepresentation and negative values are underrepresentation. So you can see the older groups, 55 plus, are overrepresented, and the younger groups, 16 to 44, are underrepresented. And then there's a group in the middle that kind of hovers around the 0, and that's kind of even. So that's the group of 45 to 54. And then for the main survey, again, positive values are overrepresented, and negative values are underrepresented. And then you can see that the groups 35 to 64 are overrepresented, and the groups 16 to 25 are under. And then you can see the group 65 plus, which is that purple line, goes from overrepresented to underrepresented by wave 10. So for the main survey, it's a period of 10 years. So this is a sample of wave 1 respondents. So the reason the 65 plus group goes from over to underrepresented is likely due to, say, death or incapacitation, where they're not able to participate in the survey. And then to summarize, my first research question about whether it's possible to achieve a longitudinal representative sample when the mode face-to-face is not available. Yes, it is possible. We saw that the representativeness remains quite high for the COVID survey, but again, we are comparing 2 different time periods. So the COVID survey was 1 year, and the main survey is a period of 10 years. So there would be less attrition in the COVID sample because it's a short period of time. However, it's still quite promising that the representation stays quite high for the COVID survey. And then for the research question 2, how does the representativeness compare for the 2 surveys? I didn't show all of the findings, but in general, there are some auxiliary variables that show similar patterns between the 2 surveys, but there are also some that are very different. So the similar groups are ethnic minorities and single people, but household composition was quite different. So the COVID survey showed that those with no children were overrepresented, and the main survey showed that those in couples were overrepresented in the survey. Overall, I think we can pick up 2 things where the main survey, it can inform the design of the COVID survey. So we know which groups would be over or underrepresented, so we can do some kind of targeted intervention, which Jamie spoke about in his slides, say incentives or targeted letters. And the COVID survey can also inform the main survey going forward, because the pandemic has kind of forced us to see what it's like not having face-to-face accessible. And in general, surveys are moving to a more web-based approach, but they've been doing it through a mixed mode fashion. So I think this shows that the COVID survey was represented, and as long as we account for subgroup biases through targeted intervention or after data collection using weights. So I've got my contact email there if you have any questions, and I've also got some references as well.